So this is the last session. We continue talking about the bubble sort. So in the bubble sort here, we will keep comparing. On the next time here, we compare 42 to 16. So which one is smaller, it goes up, and the large number goes to the bottom. And then if we find a bigger number on the next time we run, like 89. So 89 will definitely go to the bottom and 21 will be swapped, okay? And then if you can have a look at the path here, 89 is going to be bubbled until it reaches the end of the array, okay? And actually that is the running here is just one time only, one time for loop. And how many for loops we try to run? So we need to have two loops, okay? The first loop, the first loop will actually control how many times we loop through the whole array, and the second loop will go to always push bigger numbers to the bottom, okay? So actually we will be having a variable called top, and that will start to be pointing to the last element here. And then this is the one responsible for pushing large values towards the bottom. So you will keep running. So if you have 9 elements, okay, we will run 9 for loops. 9 times for loop will run, okay? So I will not talk about any code here, but I just want to have a look at the other type of algorithm that can be used. So this type is actually called, it's called sorting cards, okay? Can you see my screen, or I try to, yeah, okay. So have a look here. So the concept that they have here, they always say like that. It's like you are having cards in your hand and want to start to arrange the cards one by one. So they will say you have a current item, and this is the first thing in the array, which is 47 in this case. And they say that you have an item in your hand, and which is, they call it here item to be inserted. You have it in your hand and you want to insert it inside the array. And now we want to compare 6 to 47. Which one is smaller? 6 is smaller, okay? So 6 will be inserted, will be reversed, swapped with 47. So 6 will be in the top and 47 will go to the bottom. And then the current item, instead of becoming 47, it will become 54. And item to be inserted, sorry, I'm so sorry. The current item will be 47 and the item to be inserted will be 54. So the item to be inserted is the one in red color. Okay. Okay. And then it will check, do we need to swap them? 47 is smaller than 54, so we don't need to swap. Okay, so the current item will be 54, and the item to be inserted will be 17. So typically 17 is smaller. Okay, so it will shift up. But the magic here, it will not shift 1 point. It will be compared, 17 will be compared to 54. 17 is smaller, so it will come here. But then it will compare it also to 47. 47 is higher, so 17 will take the place of 47, as you can see here, and we will have that look here. So every time we run, we will not only shift the small number one place, we will keep shifting it up all the way to the top of the array. So that is somehow reverse what we have been doing with the bubble sort. With the bubble sort, we take bigger numbers and we keep pushing it towards the bottom of the array. But here, we keep pushing small numbers to the top of the array. So that's the difference between bubble sort and insertion sort.
Mm-hmm.
So if we try to look here, the current item and the item to be inserted, 93 and 54, there is nothing to be done. But again, we will look here. If there is a number that need to be shifted, there is nothing. So we will move to the next here to 28 and 93. We will compare them. And then we will compare after we shift 28 to become in the place of 93, we will compare it to 54. We find it smaller. So it will take the place of 54 and the 54 will come down and so on until you find 28 come to this place. See, it will keep pushing it up all the way.
Mm-hmm.
Okay, does this make any sense? Of course, we need to talk about it more, but I just what I wanted to know now that bubble sort will always work on pushing large numbers down, and insertion sort will work on pushing small numbers all the way up. Is that clear to you?
Yeah.
Okay, so we move to another concept here. Yeah. So I'm talking here now about something called state transition diagrams. Did you hear about it before?
No.
So state transition diagrams. So just let me understand from you. When is your exam exactly?
October, November.
Yeah, but the exact date, do you recall back or no?
Yeah, I did. One moment. For computer science,
Advanced?
yeah, for computer science is the 25th of October and the 31st of October.
Okay, so the practical one is 31st, right?
Yeah, practical is 31st.
Okay. So, okay, the state transition diagram and the pseudo code and also flow chart is actually always to it's a way to describe a behavior of a software solution. Okay, sometimes software solution is too complicated that it have different states. It's change its state from something to something else based on the input. So how that looks like, that's why they come up with a state transition diagram. Even the computer itself also, they make is considered a finite state machine, because when you press the power button of the computer, it changes state from being off to start again. And then maybe if you push the power button when the computer is on, it also have some action based on your input. So so what we want to say here is that we want to model devices or even software based on the input that happen to that system. If we have a system, it takes inputs, then the input affect that system. We want to study that. We want to model that with a drawing without any code. So to model that, they call that state transition diagram. So I want to explain to you here fast. Let me push that one down. So this is a state transition diagram for a door, and that door have entry code 259. So first, at the first state, we start with the door is locked. Okay, and if we have a code that is entered 259, the door will end up being unlocked. Okay. Okay, so now we have a look. This mark, this arrow actually marks the start position of the system, where the system will start. It will be always locked, and then we need to start from there. Based on the inputs, it might change, the door might change its condition from being locked to unlocked, but we need to see first what condition. So first it will take the first input, which is 2. Okay, so if it takes 2, it will go to a middle condition called waiting for the second digit, because there is 3 digits, right? First we take the first. If it takes 2, okay, it will wait for the second digit, which is 5. If it takes 5, then it will wait for the third digit. If it takes 9, it will change from being in this state to being unlocked. The door will open. Okay, so between the state of locked and unlocked, there is 2 transitions here. Okay, so now imagine that I put the first password, which is 2, and I entered, instead of putting 5, I put something other than 5. So the door will, I mean that this transition state will go back to being locked, because it means that something is wrong. So if you can imagine, if you put a wrong password, he doesn't tell you, oh, put the second entry code again. No, he will reset everything, and he will ask you to put the new password again from the start. Okay, why? Because if he only stop where you make a mistake, then he make it easy for any thief that he want to enter. So he will stop only, it will keep stopping here, waiting for you to put the correct one. So of course this will make the life of the thief easier, right? That's not what we want to do. So if we don't receive the second entry correct, then we reset the whole condition to be locked. Okay, what if when you are locked here, what if you put instead of 2 something else? Anything else that you enter will make you keep at the same position, also locked. So it will never change. You will never change your status from being a locked door to something else if you don't take 2. If you take 2, only you move to the next here. Okay, and here if you take 5, you move to the next status. But here you're waiting for 9, the last number here for as an entry code. If you don't take it, you go back to the initial status, which is locked. Okay, so now let us there is some rules when we are creating a state transition diagrams. So let us read these rules. States are represented as nodes, which is circles. So that is the states. Locked is a state, waiting for a second digit is a state, waiting for the third digit is a state, and also unlocked is a state, because it's all circles, right? So that is the rule. A state is represented by nodes, or it's in our case circles. Transitions are represented by interconnecting arrows. So here we have interconnecting arrows from one state to another. So that is a transition. Okay, you want to move from one state to another using a transition, and you represent it by an arrow. Events are represented as labels on the arrows. So that is an event. 2 is an event. 5 is an event. 9 is an event. Not 9 is also an event. Okay. Conditions can be specified in square brackets after the event label, but it's not shown here. The initial state is indicated by an arrow with a black dot. So this is the initial state, that the door is locked. Okay. a stopped state is indicated by a double circle. You see here the double circle?
Mhm.
So you start from locked and you reach unlocked and you stop there. You don't go back this way. Okay?
Mhm.
Okay, good. So I want you to look now here. Have a look, please, at this. So that is a simple state transition diagram. Can you try to explain to me what does this mean?
The user starts by
So
giving
what
in
is this circle? What is this circle? What does it mean?
that's the
State.
yeah, the state.
Okay. So we have how many states here?
Two.
Two states, which is?
Yeah. S1 and S2.
Okay. What this line means?
It's the start of a condition.
Okay, the start condition, yes. Okay, the initial, yeah, it's called the initial state. Yeah, in the state transition diagram. Okay. What does this mean? This one.
Is the transition to the next state.
Okay. So a transition is actually, are we able to say that it is an input?
Yeah.
Okay, good. So, okay, what does this mean?
That is the restart. What is it called? The stop state.
Okay, wait.
No.
No, it's not. But maybe, okay, maybe you have a look first here. This is a state transition table. You have two inputs, A and B. Okay. So for every state transition diagram, you have a state transition table. Okay. And so this describes actually what happens. So if you currently, the current state is at S1. Okay. If you are at S1 and you have input A, what will happen?
S1 input A. It will
From
move
here,
on to.
no, it's telling me here, if you are at
You,
S1 and you receive A, you will remain at S1.
yeah.
Okay. And if you are at S1 and you receive an input B, what will happen here?
You move on to S2.
So from this table, I can understand that when I receive an input B, I will move the state from S1 to S2, right?
Yep.
Okay, so if I am at S2, now I'm at S2 because I received input B. If I'm at S2 and I receive input A, what will happen to me here?
State in S2 receive S1.
No, if
Receive
if
A.
receive
go
A,
back,
yes, to
you go back to
S1.
S1. Yep.
Okay, and if you are at S2 and you received input B, what will happen?
You remain there.
So that's how it is represented by this circular arrow. Okay. Okay. Okay, that's good. Let us continue that state transition diagrams somewhere another time. But let me have quick look, and maybe we can work some more time with. Yeah, wait. So Joy, the pseudo code is actually important. So we really need to have your attention also on the pseudo code, same like we do with the Python, because at certain times in the exam he will ask you to write a program code based on the pseudo code that you have, or even complete the he will give you a program that is not fully completed in pseudo code, and he will ask you to fill it in. So we need to continue and have also develop our skills on that. So let's continue here. You already know and have seen today in the previous exercise that you are able to do a for loop using the pseudocode. The for loop inside Python does not have next. Okay, but other than that, the pseudocode and the Python have the same same concept, how it works. So have a look. Have a look here. So that is the for loop. There is two for loops here, if you can recognize.
Yeah.
Okay. Can you tell me what is this for loops trying to do? Let's look at the first one first here.
Or if the row is okay, 1 to maximum row, the row total. Oh, okay.
And here, so we look at here and look at here.
For column 1 to 10. Oh, okay. So it states that the row has 1 to infinite and the column has 1 to 10.
Okay, fine. And what is that?
Row total is...
No. I mean, that one. What this telling you? What this can tell you?
The number of row and columns.
Okay, when we see a number of rows and columns like that, does this tell me that this is an array of something? Can this tell me that this is an array or no?
Yeah.
So again, in the Python, we have 4 square brackets like that. But here is different. In the pseudocode is different. So here we have the row and the column. This is in Python. Here we have it like that. So when we look, we see that there is one for loop that's taking care of the rows, another for loop that's taking care of the columns, and then we see that figure here. So I can think with you that, oh, we have 2D array, okay, and it's the name of the 2D array is called amount, and it seems that he is trying to do some operation on the 2D array. Then we start to think, okay, what is this operation that he's doing here? He is defining or declaring a variable called total, and he's putting 0 in the total, and he having also something called row total. Row total start with 0. So the first time you run, let's look. When you first time run, row will be 1 here, right? And then column will be also 1. Okay, so the first time you run, row total will be
0, no, 1 and 1.
No. Row total here.
Oh, the total will be...
He defined it for the first time. He defined it to be 0 here.
Oh, 0. Okay.
So here will be 0, right? 0 here. Okay. We don't know what is inside here, right? But what we know is that the first time we run, row will be 1 and column will be 1. So if we have a 2D array that we don't know how many rows and columns it have, let's assume it's like that. This is the rows and this is the columns, and here 1 and 2, and 1 and 2, because this is pseudocode. It's not Python. Python will start with 0. So let's assume that this is the amount 2D array. A 2D array that's called amount. Okay, fine. So now what is this guy is doing? He is coming to here when the column is 1, and he is getting this and adding it to the row total, and also putting the result inside row total. Okay. Okay. I'm sorry. Here the columns he put it 10, but I just put it let's say like that. So it's here 10, but for simplicity we just consider it's 2. So column here, after the first time it runs, it is 1, right? So the second time it will become 2. So what will happen here?
You move on to the next column.
It move, so row will remain 1, and we only change column, right?
Yeah.
Okay, so we will get the value here. We will add it to what? To whatever we got from the first addition that we do. So it means that he is trying to add whatever was here to whatever was on the first cell. Does this make any sense to you?
Yeah.
Okay. And when he move to column number 3, what will be he doing? He will be trying to add what? He will be trying to add whatever here to the previous 2. So what do you think that at the end, after we go through all the columns here, what will be inside the row total?
Not 0. It'll be how many rows there is. How many amount of data is added.
Okay, wait. You are getting something close, but not the answer that I'm expecting. So I assume here got 10, here got 11, here got 12. This is values, okay? And at the end here 14. So first time we run, we said that we will be at this place. Okay. When we reference the array like that, we get whatever value, we add it to row total, which is 0. So 10 plus 0 equal what? 10. And so we store the result where?
Row total.
Okay, so row total now how much it have?
10.
Perfect. Okay. Now we increment the column to become having 2. So now when we are at this position, we add 11 to what is here?
10.
So 12 plus 10 equal?
21.
So row total now have 21, right?
Yep.
Okay, we move to the next column. What is inside? 12. And then you add it to row total?
33.
Like that, until we reach the end. So after you finish all the columns, what will be what will be inside the row total?
The total of the whole row.
The total of the values of the whole row, right? So the total for row and is this total. So he will print row total, and it's telling whatever was inside the row 1. Okay, after he finished row 1, he will increment row from 1 to become 2. So, and he will come here, he will do the same. He will add all the values inside. Okay. Does this make any sense to you?
Yep.
So he will keep adding. You see, after he prints this line, tell me what is he doing here?
after he output that, the total will be the total of the number
Mm-hmm.
plus the total of the row. Okay, wait. Total of the number. Oh,
So
okay. The row total.
now I want you to know this every time this for loop runs. Let me see. Okay.
It will be the row total plus 0.
Okay, exactly. So okay, and then this is for one time running this for. So every time we run, we get we add everything in the row, right? And then we move to the next row, we add everything, and we keep adding that to total. So total will be having what?
0.
No, not 0. If we go, if with this for loop, the total is called what? He will get the grand total. Means, so okay, let's say you get from this row, you get 55.
Okay.
Okay.
Then it will be 55 after the for loop is done.
After this line, the total will have 55. 55 plus 0 means total have 55. If you add the second row and you get 60, so what will be the value of total?
Oh, you add 55 and 60, so it'll be 115. Exactly. Yeah.
Yes. Okay. And if you get from the third row, you get 15.
130.
Okay. So at the end, total will have, what is the content of total at the end?
The grand total is 130.
Yeah, which is I added all the elements inside the 2D array. This is the, I added them row by row, but at the end I added everything, every element inside the array. I added them together. Does this make sense to you?
Yeah.
Okay, that's good. Okay. So we have another type of loops other than for. We have it, it's called repeat until. So repeat until means that it's a kind of loop that the condition is put at the end. Means that he will run the statement first. After this, he will check if the condition is still true. Then he will continue running the statement again until the condition it become false. So we can have a look here. See, this is an example. He say, okay, repeat output, please enter a password. And then he will take an input from the user, store it in a password variable until password equals secret. So what does this mean in your opinion?
It will repeat the output of the that the user enter the password until it enters the password that is exactly word to the word secret.
Exactly. Perfect. Yes. It's good. It's good. Yes. Okay. So yeah, that's excellent actually. Okay. And actually, sometimes this kind of loop is needed so that you don't repeat lines of code. You will understand that next. So here we use while. This is a different type of loops, similar to this. How to say? Similar to this repeat until, except that it checks the condition before it runs. So he is telling while number bigger than 9. Before he run to this line, he will check first, is it the number is bigger than 9 or not? If it is not bigger than 9, it will not even run one time here. But the other repeat until is different. He will run for the first time. He will run at least one time this before he check this condition. But with a while, no, the condition need to be satisfied first before he can even run this even one time. So if here the number is equal 10, this line will never run. If it is how to say, if it is 8, sorry, I told you something wrong. If number bigger than 9, it means that number need to be maybe 10, 11, 12. If it is 8, it will not run. Does this make sense?
Yeah.
Okay, so if it is 8, we will not run, right? But now, what if it is 10? What will happen here?
It will run. So the
number,
the number will be 10 minus 9, so it'll be 1.
Perfect. Okay, here he's talking about procedures again, and we already know procedures. Let us see. So that is how he defined a procedure. That's how he call it, with the values, if it have values, parameters. Let's have a look here. That will be the last thing that we explained. See here. Are you able to tell me here? Start from looking here, please.
Sorry, sir. My screen, I'll join from my phone for a while.
Okay. Okay, good. So, recording is... Can you hear me?
Yeah.
No, I think you have to off one of your. Yeah, you have to mute one of your, either the phone or the PC.
Okay. The thing is, I can't see the screen.
You can't see it.
Okay, I muted there. Okay, yeah. So if the size is default, which is then you call default square.
If not,
the function. If not, you call the function square size.
Okay, so it means that there is two different things that we will call based on this if condition, right?
Yeah.
Okay, so if it is size equal default, means that we don't need to enter any size, and we call the default square. Where is this default square? This is the default square. Okay, so the default square will call square with 100, which is fixed. He considers this is the default size. Okay, if it is not, he will call this square, but he will give it a size here, which is what was passed here. Okay, so can you check here what is he trying to do inside?
If the procedure square